Hello. For the central limit theorem, I don't think I really need that. When you're doing this problem, the average amount of money spent for lunch per person in college cafeteria is 6.64 and standard deviation of 2.61. Suppose that 49 randomly selected lunch patrons are observed. Assume the distribution of money spent is normal. Round all answers 4 decimal places where possible. Okay, so the first one, what is the distribution of x? Now this is just saying the mean and the standard deviation. And so you would just put your mean, 6.64, standard deviation, 2.61. Now the distribution, this one, notice it has an average, the line on top, which means they're taking a sample. This is the mean from a sample, or this was the whole population. So from this sample of 49, the mean stays the same, but the standard deviation does not. The standard deviation, let me move this for a minute. When you have a sample, it's the mean divided by the square root of n. So our mean was 6.64, or sorry, not the mean, it should be the standard deviation. So our standard deviation was 2.61 divided by the square root of our sample size, which was 49. I think it said 4 decimal places. Yeah. So you should get 3.729. 0.3729. So this is when you're taking a sample. Now when you're finding your distributions, if you're using any random person, then you use part A. If you're using a sample of 49, then you use part B. Okay, let's look at C. For a single randomly selected lunch patron, find the probability that this patron's lunch is between 6.8107 and 7.1972. Okay, so to find that, this is a randomly selected, so we're using the mean and standard deviation from part A. Now if you're using Excel, you have to do them separately, because you have your 6.8107 and then your 7. Now, when you use the inverse here, it gives you the percent below. So when we use this value, it's going to give us this. When we use this one, it's going to give us all of this. So if we subtract our 2 answers, we get what's in between. Oh, sorry, I was writing and you're not even seeing it. So when we find our value, if we use this, it's giving us the percent below. When I plug in this one, it gives me all of this. So if I subtract the 2, it takes this out and leaves just this. So we would go equals norm, and we want the normal distribution. So we want the first one. And then you put your x value, 6.8107 8107, comma the mean 6.64, comma 2.61. Now this also wants the cumulative. Well, under your curve adds up to 1, so you just always put a 1 and then hit enter. So this part right here is 0.526073. Now we want the same thing, but we want to put this value in. Instead of typing it again, oh yeah, I will. Equals norm distribution. And then we put our x value. This time we use this one. Comma your mean 6.64, comma 2.61, comma 1 for cumulative. Look at this. Now this is from here to here. It's 0.584526. So this is the whole thing. If we subtract this, it'll take this out and leave what we wanted between the two values. To subtract them, equals, and then you click on the one you want, this one. Notice it put A2 minus A1. You get 0.0584. To do it on the calculator is a little bit easier. When it's in between, you go to distribution. It's right here in blue. So second distribution. It's the second normal. And then your lower value, because see, it will already subtract it for you. Our lower value was 6.8107, and the other one was 7.1972. I don't know why that's so dark today. There we go. And then your mean 6.64. and the standard deviation 2.61, and then paste it and hit enter, and there's your value. So when you're using the calculator, it goes between two values rather than just below. Now the difference between C and D, they're using the 49 patrons rather than any single randomly selected patron. Since they're using from this group, the only difference is your standard deviation. Since they're keeping the same numbers, then we could go here and change the standard deviation to 0.3729. And hit enter. And then on this one again, go back in and change just the standard deviation. 0.3729. And it's already subtracted them for us. 2.56. And the calculator distribution, the second one, the values are still there. The only thing I need to change is my standard deviation, 0.3729. And there's your answer. So either one. And then for part D is the assumption that the distribution is normal and necessary. The reason it's not necessary, your sample size is greater than 30, so it's not necessary. Okay, this one here, suppose the average number of Facebook friend users you have is normally distributed with a mean of 126 and a standard deviation of 45. Assume 7 individuals are randomly chosen. Answer the following questions. Round all answers 4 decimal places. Okay, so this one, notice it's not the capital X, it's the X with the line, so it's from the average, which means the mean will be the same, but for the standard deviation, you take your standard deviation and divide by the square root of the sample size, and the sample size was 7 individuals. (45) divided by the square root of 7 is 17.0084. I think they wanted 4 decimal places. Okay. Find the first quartile for the average number of Facebook friends. Okay, quartiles are broken into quarters, so 25% of the data is below the first quartile. And then the median is the second one, 25%. And then if you needed the third quartile, another 25%. And then this is your largest number. And your smallest. So if you want the first quartile, 25% of the data is below it. If we're using Excel, let me delete what's there. We go inverse, and now we still have the percent. Since we're getting the number when you type in norm, we want the inverse. So you want the second one. Because then notice it's asking for the probability, and our probability is 25%, written as a decimal. So 0.25, comma, your mean, 126, comma, then the standard deviation for the average, because it was the group of 7. 17.0084. And then hit enter. Oops. Oh, sorry, I was doing C. We'll go back to B. So for the first quartile, it would be 114.528. 25% of the data would be below it. If you needed the third quartile, then instead of 0.25, you would make it 7.5. That would be your third quartile. 75% of the data would be below it. For this number, or B, it's still from the group of 7. Find the probability that the average number of friends is less than 119. So that would be equal, whoops, norm This one's the distribution because they're giving us the number. We want less than 119. So it's 119, comma, your mean 126, comma, your group standard deviation 17.0084. Cumulative is 1, and hit enter. And there you go, 0.3403. To do it on the calculator, under distribution, the part B would use normal CDF. Now we're doing less than 119, so it's 119 and lower. So you want to do a large negative number. And then the upper is 119, the mean 126, standard deviation 17.0084. Make this a little smaller maybe. Oh, I think I used a negative instead of a minus. That's what it was. Why isn't it? I don't know why it didn't work the first time, but it did this time. It was saying I was putting a minus, but I thought it put a negative. Why that one's not working. Distribution, normal, negative, really small negative number. 119, 126, 17.0084. There we go. I don't know what I hit that it wasn't. I must have had something typed wrong. But there you go. Then for the other one, when you're trying to find the number and you have the percent on the calculator second distribution, it's inverse norm. Your area for the first quartile, 25% of the data is below it. Your mean, 126. And the standard, 17.0084. That is